Now we have what refers to your book as 12.6, so multiplication of polynomials and special products. Multiplication of polynomials. To multiply monomials, use the associative and commutative properties of multiplication to group coefficients in like bases. Simplify the result by using the properties of exponents. So here are two examples. We're just going to follow these rules here. So here we are going to just combine these bases because we can use the fact that multiplication is associative and commutative to just rearrange the 5 in front. So now this just becomes a question of what we went over last week of what is b to the 4th times b to the 5th. Well, we know that is b to the 4 plus 5, which is 9. And that's it. So over here, we're going to do the same thing. Rearrange so that it's 4 times a squared times negative a to the 4th times b to the 7th. But here with this negative, remember that's just a negative first. So I can pull it out in front and now say this is negative 4 times a squared times a to the 4th times b to the 7th. Last, we're just adding the 2 and the 4 for the a's. And then remember that there's an invisible 1 right here for that first b. So that's 1 plus 7. So we get negative 4 times a to the 6th times b to the 8th. And that's it. So for polynomial, so now, right, if we've got an addition and subtraction between them, remember this is a monomial, 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 monomial. This is a polynomial, right? There's two. There's more than one. Poly, multiple. We're going to use the distributive property to then combine like terms, like we used to do in 12.5. So I'm going to work on the evens, okay? Or actually, no, I'll work on the odds. So that you have 3 examples to show you. So we are just going to multiply 3 by distributing the 4xy to 2xy minus 3x plus 6y. So first, 4 times 2 is 8. X times x is x squared. Y times y is y squared. Minus 4 times 3, which is 12. X times x is x squared. And then remember there's a 1 invisible after the x. So we just have the y that stays on. And then plus 4 times 6, which is, what is that, 24 x y squared. Now just make sure that there's no like terms to combine. There are not, because this term has an x squared y squared. This term has x squared y, and the last term is xy squared. So these are all different terms. For b, how we're going to multiply is still using the distributive property. So everyone gets multiplied by everyone. So the b gets distributed. I like to work my way left to right. So the b gets distributed. You have b times b, which is b squared. B times 6, which is 6b. Now that the b has exhausted everything in the second polynomial, we move to the second term in the first polynomial, which is negative 4. So now we have negative 4 times b, which is negative 4b, and negative 4 times 6, which is what, negative 24. We combine like terms, which are the b's. So this is b squared plus 2b minus 24. Also, at this point in the game, many of you may know FOIL. FOIL's all right. It definitely gets the ball going, but it makes it hard when there are more than one term. More than 2 binomials, or if you have a trinomial or larger polynomial that you're trying to distribute. So remember, FOIL stands for the first, outside, inside, last. So first, outside, inside, last. You don't have to do it in that order. That's just a fancy little fun term to help everyone remember. But if you want to remember FOIL, that's okay. But just remember it's underneath the distributive umbrella. All right, next up, we've got 5a times 2a, which is 10a squared. 5a times 3b, which is plus 15ab. Negative 4b times 2a is negative 8ab. And negative 4b times 3b is negative 12b squared. So now our inner two terms are, quote, like, right? Because they're the terms that have ab. And we are left with 10a squared minus 7ab minus 12b squared. Oops, forgot my equal signs. And there you go. So going on to the next page. Make sure I'm on screen here. Yep. Okay. So here, same deal. You've got the 2 that gets multiplied to everything, right? Then the 3 gets multiplied to everything. And you can go through by that, like I showed you a minute ago. Or I'm also going to show you the box method, just so that it's another tool in your toolbox. Okay, if you just Google box method, this should come up. But along the top, I'm going to have my second polynomial. And on the side, I'm going to have my binomial. So notice I've just got all of the terms. It's okay if you have the 3 down in a column and the 2 in a row. It doesn't matter. It all kind of comes out in the wash. Now, to get each cell, all you do is you multiply the outer numbers. So for this cell here, we'd have negative 3 times 6a, which is negative 18a. Say for this cell, we have 2a times 9, which gives us 18a. Now I'm just going to fill the rest in. 2a times 4a squared is what? 8a cubed. Then we have 2a times 6a, which is 12a squared. Negative 12a squared, and then negative 27. And what's cool about the box method, if you look at the diagonal cells, those will always combine. So now when you're finished, you've just got 8a cubed. And then, oh, see, even here, I noticed I made a mistake. See, I know that's an a squared, because they should always combine. So I know I made a mistake. So that's also really nice about the box method. So minus 12a squared plus 12a squared, they reduce each other out. Minus 18a plus 18a, those reduce each other out. So we are just left with, this is equal to 8a cubed minus 27. Which here, in the page down, will lead us to perfect square trinomials. So this is a little something more to come. It's also called the difference of cubes, because 2 cubed is 8. Here, hopefully, it's obviously the a is cubed, and 3 cubed is 27. It's something called the difference of cubes. Okay, so now this method is very similar to the box method, but rather than doing it like the box, it just has it set up similar to how we would do, multiplication on the other. So I'm going to leave that for you. If you have questions, come to class. Okay,